everyone, my name is Kachan and I'll be showing you the equipment and materials needed for the single socket outlet installation. The equipment and materials we'll be using for this installation will be two 2.5mm copper cables, a wire cutter, a flathead screwdriver, a single socket outlet, and a double single socket outlet. The socket outlet should have a cerium sticker on top of it.
Hello, my name is AMRIN and I will be presenting my group for this project. In this video, I will be showing you how to install a single socket outlet. Okay, in this session, we will show you how to connect these three wires to the DB. The three wires is, one of them is the green one, which is the earth, the black one, the neutral, and the last one, the red one, is the live. Next is stripping the wires. Don't forget to use the wire cutters. And also don't forget that we need to twist the copper wire so that it will be easier to connect. Using a flat-headed screwdriver, connect it to the C16 MCB and screw it up. Now we have connected all the three wires to the DB. The wires that we connected just now was earth to the earth terminal and neutral to the neutral terminal. Next, we are going to connect the SSO to the three wires right here. The wires that we will be attaching to the point, there's 3 points right here. First one is L, the live, the ground, and N, neutral. First point is the L. Connect it and screw it with a flat-headed screwdriver until it's completely tight. Second one is neutral, right there. Screw it up. And the last one will be the earth, right in the middle. Put it inside and screw it up to the point it won't come out, just like that. The other type of single socket outlet is a double single socket outlet. It has the same feature as a single socket outlet, but the difference is this type requires two earth terminals, and now we will be connecting them to the wires. Firstly, the earth wires. We're connecting them, which is the earth terminal will be at the top. Connect them and screw it up with the fillet screwdriver until it's tight. And the other earth wire. The live will be connected right here. Unscrew it up. And don't forget to twist the wires out, just like this, so it'll be easier to connect. Put them in. Do not let the copper expose right after you screw it down. Lastly, the neutral wire. It will be connected right here at the N terminal and screw it up. And there you have it. the wiring for this project is complete.
Now we'll continue with the testing for the circuit. The first testing we'll be doing is the continuity test. First, we'll set the AC clamp meter to the resistance setting, and now clamp it onto somewhere secure onto the trunking. With both of our hands free, we can now start doing the testing. The first point, which the red probe will put it onto point A, as you can see on the graph, and then the black probe will put it onto point D. If everything is connected properly, the meter will start beeping and will show a reading. The next one is for the neutral to neutral, which is from point B to point E. And then the last one is from point C to point F. While the meter might fluctuate in resistance shown, it is for the most part just fine, as long as it will continue showing a reading even if it's slightly unstable. Now we'll continue on with the insulation test. This will be insulation tester we'll be using. So to use this, first we must turn it on to the 250 volt setting. Now we'll have to put the two probes onto the two different points on the socket. Right now it's connected to the line, live and the neutral. Now we can press this button. We can also hold this button. We can spin the button here for it to hold. And now my hand is free to switch between different points of the component. Now we're doing neutral ground, which is still OL. And now live ground, which is also OL. The components should, when doing the insulation test, the result should be OL, which is overload. Yeah, when doing the insulation test, the result should be OL across the board. Now that we've finished our insulating and continuity test, we'll move on to the live test. After connecting the circuit to a power source, we will turn on the DV box from the right side, and then turn off the second part and press the test button. If it jumps, that means there is currently electric power running through it. If it does not, then we will have to check our wiring. Now that it did, we can push it up again and then move on to turn on the proper MCD. This will be our tester. So turning on the SSO should show all three lamps are now lit, which is based on here correct. And then we can, so that's live test completed.